Okay, in this recording, I'm going to be showing you how to solve absolute value inequalities. So first, recall that absolute value makes whatever is inside the absolute value positive, no matter what x is. So let's take, for example, an inequality with absolute value of x plus 4 is greater than 7. And I need to solve this inequality. So because of this rule up here, I know that either the inside stuff as a positive number will be greater than 7, or I could have had the negative inside stuff be greater than 7, since the absolute value would have turned this negative into a positive. And here now I'm just solving a linear inequality. I subtract 4 from both sides to get x is greater than 3. Or I distribute this negative, add 4, and then because I have a negative x, I can divide it by a negative 1 to get a positive x. And I divide the 11 by a negative 1 to get negative 11. But if you recall with your inequalities, whenever you divide or multiply your variable by a negative number, you switch the direction of your inequality symbol. So whereas this used to read greater than, now it'll read less than. So here, to map out the answers I've gotten on a number line, if we have negative 11 down here and a positive 3 up here, I have x has to be greater than negative 3, so I'll have an open circle at 3 and an arrow shaded to the right for all numbers greater than 3. And I'll have x is less than negative 11, so I'll have an open circle at negative 11 because x can't equal that number, and shade to the left because I can have all values less than negative 11. And now I'm just going to do a quick check. Suppose I have a number that's less than negative 11, such as negative 12. Negative 12 plus 4 is negative 8, but when I take the absolute value, I'll get a positive 8, and it is true that a positive 8 is greater than 7. I'll check a number bigger than 3, so let's say 4. 4 plus 4 is 8, and absolute value of 8 is 8, and 8 is greater than 7. So I know both of those situations work. And now I'll just test a number inside to make sure it doesn't work. So the easiest number for me to test between 3 and negative 11 is 0. 0 plus 4 is 4, and the absolute value of 4 is 4, and 4 is not greater than 7, which is why none of the values in between 3 and negative 11 work. So if I'm writing my solutions, I can write that x is less than negative 11, and x is greater than 3. And this is an OR situation, even though I just said AND, I think. Okay, so we have x is less than negative 11 or x is greater than 3. And this is an example of a disjunction. Because we can have either piece, and you see they're going in opposite directions. So doing another one, let's take, for example, and let me get a fresh slide. Suppose we have to solve the inequality absolute value of 2x minus 3 is less than or equal to x plus 1. And that tells me either I can have 2x minus 3 is less than or equal to x plus 1, or the negative 2x minus 3 is less than or equal to x plus 1. And over here, add 3 to both sides, and I'll get 2x is less than or equal to x plus 4. And then subtracting x on both sides, I'll get x is less than or equal to 4. Over here, I'll distribute this negative to get negative 2x plus 3 is less than or equal to x plus 1. And it's important to remember that when you're doing these inequalities, or any absolute value, when you take the negative answer, put whatever's inside the absolute value bars in parentheses so that you don't forget to distribute. Otherwise, you may fall into just writing negative 2x minus 3. And now here, I will add 2x to both sides to get 3 is less than or equal to 3x plus 1. Subtract 1 from both sides to get 2 is less than or equal to 3x. And then divide by 3 to get x is greater than or equal to 2/3. So here, when I map that out, I have x needs to be less than or equal to 4. So I'll put a 4 here and a closed circle at 4 because x is allowed to be 4. And then I would have to shade to the left. But I also have x needs to be greater than or equal to 2/3. So let's say 0 is down here, so let's say 2/3 is right here. So I put a closed circle at 2/3 because x is allowed to equal 2/3, but it has to be bigger than 2/3. So I would be shading to the right. And you see here now, I have a situation where I'm less than 4 and equal to 4, or greater than or equal to 2/3. So I can really fuse these two arrows to create one line that has endpoints at 2/3 and 4. So this is an example of a conjunction where our answers are x is greater than or equal to 2/3, and, because it's a conjunction, x is less than or equal to 4. And we can write this conjunction as one line and say 2/3 is less than or equal to x, forgive my dog, which is less than or equal to 4. So any number between or equal to 2/3 and 4 will work when we plug it into our original absolute value inequality. And I'll just check that. So I'm going to check a number between 2/3 and 4. Let's try 1. When x is 1, 1 times 2 is 2. 2 minus 3 is minus 1. And the absolute value of minus 1 is 1. And when x is 1, 1 plus 1 is 2. So I have 1 is less than or equal to 2, which is correct. I'll test a number outside of these boundaries. So I'll test 0, which is less than 2/3. When x is 0, 0 times 2 is 0, which goes away, and I'll have negative 3. And the absolute value of that becomes a positive 3. But when x is 0, I'd have 0 plus 1 is 1. And a positive 3 is not less than or equal to 1. So 0 will not work. So I know it has to be bigger than the 2/3. If I tried 2/3 and plugged it in here, you should end up getting the same answer on both sides. So 2/3 times 2 is 4/3, minus 3 is minus 9/3, and 4/3 minus 9/3 is minus 5/3, and absolute value of minus 5/3 is 5/3, and then 2/3 plus 1 is 5/3. So those were equal to each other. That will also be true for 4. 4 times 2 is 8, minus 3 is 5, and the absolute value is 5, and 5 plus 1 is 5, so 5 equals 5, and that's true. But if you tested a number bigger than 4, it will not work out. So you can try that on your own. And I'll do one last example with a quadratic this time. Suppose we need to solve absolute value of x squared minus 4 is greater than 3x. So here I either have the situation where x squared minus 4 is greater than 3x, or the negative x squared minus 4 is greater than 3x. Over here, I'll subtract 3x from both sides to create one quadratic in relation to 0, because I know how to solve quadratics for 0. And over here, I'll start by dividing the negative on both sides. And when you divide the side with the variable by a negative, you switch the direction of the inequality. Now I'll add 3x to both sides. So I have two inequalities, both of them are quadratics, which I can factor. I can either have x minus 4 times x plus 1 is greater than 0, or an x plus 4 times an x minus 1 is less than 0. Now for this one, I know if I map out a number line here, when x is equal to 4, I'll have 0. Because 4 minus 4 is 0, and 0 times anything is 0, and that won't work out for my inequality. I also know when x is a negative 1, I'll get 0, because negative 1 plus 1 is 0. And now I'm going to test a number in between negative 1 and 4 to see what happens inside. So I'm going to test 0, which is the easiest number for me to try. If x was 0 here, 0 squared is 0, minus 3 times 0 is still 0, and I'd have negative 4. But negative 4 is not bigger than 0, so all of this area will not work in my inequality for this side. I'll test a number smaller than negative 2. Negative 2 squared is 4, 4 minus 4 is 0, and negative 2 times negative 3 is a positive 6, which is bigger than 0. So this side will work. And I'll test a number bigger than 4, such as 5. 5 squared is 25, minus the 4 over here is 21, and 5 times negative 3 is minus 15, so 21 minus 15 is 6, which means this side will work for me also. So for this side, I've now created the situation where I have x is bigger than 4, or x is less than negative 1. Over here, I'd have zeros at negative 4 this time and a positive 1. Testing a number inside, such as 0. 0 plus 0 minus 4 is minus 4, which is less than 0. So all of this side works. Testing a number bigger than 1, like 2. 2 squared is 4, minus 4 is 0, and 2 times 3 is 6, which is not less than 0. So none of this portion will work. And testing a number smaller than negative 4, such as negative 5. Negative 5 squared is 25, minus 4 is 21, and negative 5 times 3 is minus 15, and 21 minus 15 is 6, which is not less than 0. So for this one, I have the number line where x is less than negative 4 or greater than 1. So now what I'm going to do is fuse the two number lines together. And my critical values here were a negative 4, a negative 1, a 1, and a 4. Okay, so for this side, I had all values less than negative 1. So I can shade this way. But that means that if I'm allowed to use negative 4 for this side, even though I wasn't allowed to use it here, it is a possibility. So this open circle now is a closed circle, and I have shaded everything this way. I also have that x is greater than 4, so I can shade this way. And now that takes care of this side. Over here, I'm going to use this number line, and I have that x is less than negative 4, but that's already encompassed in my fusion of the two number lines. and I have that x is greater than 1. Oh, and I just caught a mistake that I made before. Up here, I shouldn't have made this number line like this. I should have had open circles at -4 and 1 and a line between them, because that's where my checks were. So my apologies for confusing you with that. So now let's go back. I do still have the situation where my open circle at -4 is filled in by x being less than -1. And now x greater than 4 is filled in here, and my open circle is at 1 here. So over here, I am allowed to be less than 1, because I'm allowed to be between 1 and -4. So this open circle stays, but if I'm allowed to be less than 1, ultimately I will fill in this open circle at -1. So what I've just done now is created an open circle at 1, and every value less than 1 is allowed. And I still also have every value bigger than 4 is allowed. So ultimately I have the disjunction x is less than 1 or x is greater than 4. And I'm just going to test that. When x is less than 1, 0 for example, I'd have 0 squared is 0, minus 4 is minus 4, and the absolute value of that is 4. 0 times 3 is 0, and 4 is bigger than 0. So this side will work. And when x is bigger than 4, let's say 5, 5 squared is 25, minus 4 is 21, and the absolute value of 21 is 21, and 4 times 3 is 12, and 21 is bigger than 12. So here my solutions are x is less than 1 or x is greater than 4. So now I'm going to give you a couple practice problems. So for the first one, solve the inequality 2 times the absolute value of 1/4 x is greater than 1. And for the second, solve the inequality minus absolute value of 4x plus 2 is less than or equal to 6. So pause the recording here and work out your solutions, and when you're ready to compare with mine, you can play back. And I'm going to start my solutions now, so hopefully you've had enough time to pause and get your answers. On the left, I'm going to start by saying I either have, and actually I'll start by dividing both sides by 2 to get rid of this and only have the absolute value of 1/4 x is greater than 1/2. And that means I either have 1/4 x is greater than 1/2 or a negative 1/4 x is greater than 1/2 because of the rules of absolute value. And now here I can multiply both sides by 4 to get x is greater than 4/2, which means x is greater than 2. On the right, I'll have a negative 1/4 x is greater than 1/2. Multiplying both sides by a -4 gives me an x and a -4/2. But since I multiply a variable by a negative, that means I have to switch the direction of my inequality. And that means x is less than -2. So here I have the situation where x is either less than 2 or less than -2 or greater than 2. So I have the disjunction x is less than -2 or x is greater than 2. And you can check those answers to make sure they work. And check in between -2 and 2 to make sure they wouldn't work. Now, number 2 is kind of a trick question that I gave. Because here I have absolute value of 4x plus 2, and no matter what all that stuff is, no matter what x is, absolute value of the stuff will always be a positive number. So this part here will always be positive, but then when you multiply a positive number with this negative out front, a negative times a positive will be a negative. And now we have some negative number, depending on what x is less than or equal to 6. But that's always true. Since 6 is positive, and any number over here will be negative, it will always be true that the negative number is less than the positive number 6. So no matter what value for x we choose, it will be a true inequality. So we can just say all real numbers are possible for x. And that's the little shortcut here. Now, if you didn't realize that, you could have set up the situation as either a negative 4x plus 2 is less than or equal to 6, or the positive 4x plus 2 and then add the negative, or you could have had the negative 4x plus 2 less than or equal to 6. And here, I'll divide both sides by the negative, which will switch the direction of my inequality. I'll subtract 2 from both sides and divide by 4 on both sides, which gives me x is greater than or equal to 1. Over here, I see that I have a negative negative, which will become positive. So I'll just have 4x plus 2 is less than or equal to 6. But I'll subtract 2 from both sides to get 4x is less than or equal to 4. And dividing by 4 on both sides, I'll get x is less than or equal to 1. So now if I chart both of them on a number line, let's say here's 1. I'm allowed to equal 1 for this one, and any number bigger than 1. So I can shade to the right. For this one, I can equal 1 as well, and I can be any number less than 1. So I can shade to the left. So you see here that ultimately I'm just creating the entire number line. Every value for x can get used, which is why x can be any real number.